All right, number 9. Number 9 says, find the x and y intercepts and graph it. And let's go through it. All right, let's go through it. And I'm going to go back to the my graph paper. I'm just reusing the paper, so I'm just going to erase. And let's go for it. So again, we're doing number 9, right? And what's number 9? 3x. Let's see, equals 9 minus 5y. All right, what I want to do is, I just want to put down what they're asking to do, which are the x and the y intercepts. And there's a point to this. So for example, if I select y to be 0, I would get 3x equals 9. That's relatively simple, all right? 3, 0, very, very simple number. If I choose the x to be 0, though, what are you going to get? You're going to get 0 equals 9 minus 5y. And if you solve that equation, you would get 5y equals to 9, or y equals to 9/5. This is where a lot of students struggle. However, if you're not struggling with this is fine. What's 9/5? It goes in 1 4/5. But what I want to do is, I'm going to plot it out. I want to get another integer solution to the problem, all right? And I want to just, briefly talk about solving this thing for y. So I'm going to put down 5y equals, let's see, minus 3x plus 9. And then I'm going to divide both sides by 5. What do you get? Minus 3/5 of an x plus 9/5. Now, by the way, this doesn't make it easier for anyone at this point. But I do know that y is a function of x at this point, all right? Let me repeat what I did. I added 5y to both sides, I subtracted 3x from both sides, and I divided both sides by 5, all right? Now, granted, you can plug the numbers in if you want. For example, 0 would give you 9/5. We're expecting that. By the way, I'm looking at this equation here. And if I took x to be 3, what would you get? Minus 9/5 plus 9/5, which is 0. But I want to claim there's another reason for doing this. And the reason for doing this is I see a counting problem over here. And I want to point out the counting problem I'm seeing over here is, I'm going to say the y's are going down by 3 when the x's are going up by 5. All right? So what I want to do is I want to look at this number here, and I want to go up 5 on 3. What number would I get? I would get the number 8. We'll check it, though. All right? And if you went down 3 from 0, you would get minus 3. I want to check this for you, though. And someone says, where are you going to check it? I'm actually going to check it right here. And what do I get? What's 3 times 8? It's 24. 9 minus. What do you get there? I mean, if it's minus 3, you get plus 15. Wow, that worked beautifully. So what I want to do is I want to graph it out. We'll go back to the question in a moment, though. I'm going to plot out 3, 0. Get my red pen out. And then I'm going to plot out, 8, and then I'm going to put the minus 3 down, all right? So I'm counting. 3, 6, 7, 8, down 3. I'm going to get my little ruler out. It's tough. I'm not saying it's going to be easy for you to do this. I'll put this over here. Roughly, it's roughly. I'm not going to say it's perfect. Put my little line through here. Let me get rid of my ruler. Put arrows over here. And someone says, I wonder what you just did over there. I drew a line through the 2 points. What 2 points? 3, 0. That's right there. And the other point I put down is 8 minus 3. All right, 8 units over, and then 3 units down. Question is, did I hit the other point, which is 0, 9/5? Well, I'm going to say it's over here. I'm going to say this point over here is 0, comma, 9/5. Well, I hope you realize that 9/5 is 1 4/5. That's 1 4/5 up. Now, granted, I could not have measured that looking at that, but now I'm going to agree with it. It looks pretty good, all right? We're done. Thank you.